Okay, so once again, you are welcome to today's lesson. Okay, and for today's lesson, we are going to look at how to find the range of functions. We know how to find the domain of a function. And in my introduction to the domain of functions, I made use of what? Range, and equally the codomain. So my point is, these two, they are related. They are connected. Okay, when you know the domain, you should know the range of a function and vice versa. Okay, however, if you remember in my introduction to the domain of a function, I said that the domain will be in terms of the x value and the range will be in terms of the y value. If you remember the mapping, okay, that I used to carry out this explanation. Okay, so at the end or by the end of today's lesson, you should all know how to define the range of a function and equally how to find the range of what of functions. So basically, that's what we are going to do today. I'm going to define the range of a function for you, and out of that definition, we will use it to generate certain steps that will help us find the range of what of functions or find space. So let's look at what range of functions. The domain was defined as a set, if you remember, and equally my explanation to the domain, I stated the range also as a set. So it means the range will also come as a set. So the two will all be what set. So this is it. This is the simple definition of what of a range. However, maybe before I write it, let me find out. Okay, from the definition of what of the domain, can you give me, or I want someone to give me the definition of a range? Just try. Look at the definition of a domain. Okay, and remember I've given you a vital information. The domain will be in terms of X. So the range will be in terms of Y. So try to connect this sort of concept, okay, in more or less editing your definition for the domain to suit that of the range. Any ideas? Okay, in any case, what is a domain? If you see this question, this is the only question in your terminal exam. What is a domain? How would you, okay, set yourself up to pass? Any ideas? Because I've taught you what I know that usually you are not bothered with the definition. You just know how to solve questions. But you should know the definition as well. Because everything that we are going to do will be based on what the definition. So anything that the concept starts from the definition, it means we equally want you to know the definition. So please make me proud. I'm waiting. Hello, are we there? What did I say? That the domain of a function is.
Mr. Hackman,
Yeah, Debbie.
the domain are the values that can fit into a function.
The value that can fit into your function. Okay, not bad. But usually when we are defining the domain, we use certain variables. So that is what I'm looking for. And I also saw that in your definition there was a keyword left. or which was not mentioned. So I cannot take that, okay, as maybe 10/10 answer. But it's a good try. Okay, any other idea?
Sir,
Yes, please.
the domain of a function, for example, fx, is the set of the possible values of x, which makes fx defined.
Which will make the
Okay.
function defined. Okay, very good.
Yeah.
So once you get, you can see that the domain is defined in terms of, so if I have a function f of x, the domain is defined in terms of x. Okay, and I said the domain will be your x what value. And if you realize in my introduction, basically, or what I've said today so far, you can equally take this from, okay, the statement that I've made so far, that the range will be in terms of what? Of y. So the range will be the set of values of what? Of y. So that's how we are going to proceed. So I'm going to start, and maybe you see how you can define the definition of that of what? The domain to fill that of the range. So that anytime you know one, you will know that the other is automatically known in terms of its definition. So the range of a function, okay, f of x or y, because I told you that f of x is the same as what? Y usually. Okay, if the set of values of x, okay, sorry, forgive me, of y, because we said the domain will be in terms of y. Okay, and if you look at the, the range will be in terms of y. But if you look at what the definition of what? Of the domain, we said it will be the x that will make y defined. I hope you get it. That is f of x defined. So it is the opposite this time around. So it will be the y that will make what? The x defined. Is my point well made? Hello?
Yes.
Am I clear enough?
Yes.
So I'm saying we're asked, okay, the domain of a function is the set of values of x, the set of x that will make the y defined. The range will be the set of y that will make x defined, or that x is defined on. I hope you get my point. So it's just a matter of interchanging your x and y, okay, in the definition, and you are fine. So in this case, I would say the set of values of y, okay, for which, okay, x is defined. As simple as that. And the domain will be the set of values of x for which y is defined. Simple. So the domain is in terms of x, the range is in terms of y. Okay, so now that we know this definition, let's look at how to find the range. So to find the range, okay, of a function, okay, these are the steps. Step one, okay, let y be equal to the function, because there should be y in place. However, if the function comes in terms of y, then this step will not be necessary. But only the function will always come in terms of maybe f, j, okay, what have you. But if the function is given maybe y is equal to, you are not supposed to carry out the first step. So that's the first step. Okay, the second step, okay, is to make x the subject, okay, of the relation in step one. Am I clear enough? Are you following? Okay, very good. So you make x the subject because you want to find, okay, your value in terms of y. If you make x the subject will be in terms of y, because after equating y to f of x, you now get y is equal to a certain expression here, which will involve x. But this time around, you make x the subject, unlike the, what do you call it, inverse of a function, where after making this representation, you interchange and make y the subject. But here, after getting your representation, okay, what do you interchanging of variable, swapping of variable, but you just make x the subject straight away from that was relation that you have there. But that is not the end. Okay, so step 3, find the domain of, okay, your x. So it means now your function will be in terms of x. Or find the, so let me put or the domain of the, or the result in, okay, step 2. So in step 2. So your step 2, you make as the subject. So you get a relation here, and you come and subject that function or that relation that is here. You, okay, how to find the domain. And immediately you find the domain of the result that is here. Okay, then automatically you get the range. So then, okay, what do you call it for? The range then becomes the result in, okay, step 3. I will throw a little more light on that. Okay, so this is how you form your domain. So with this, the range, remember we said, so IE, so this is how you shape your range. Your range will be, so therefore the range of your function, okay, so let's say f of x will be equal to that one. You also start with what? You're saying, okay, it will be x respect that x, but because the domain is in terms of, sorry, the range is in terms of y, you write y is such that y belongs to a set of real numbers, but you don't end there, comma, your restriction, if possible, or your condition. So you can see that it has some sort of connection with what? With your domain. Only that the domain will be here will be x, but for the range, this here will be what? Y. Okay, so it will be y is such that y belongs. So it means if you are finding the range, if for nothing at all, just like I said for the domain, you should have what? This, okay, taken. Then it's your restriction that will come from your analysis. And now that we all know how to find the domain, so we are supposed to find the domain of the result, okay, in step 2. So we'll get there. Okay, so you just don't worry. So easy. Once you know how to find the domain of a function, okay, at this point you find the domain, and the domain then becomes what? Your range. Okay, so if you like, I can equally frame this way. Then the domain of the result in what? 3 becomes what? Your range. Or the range then becomes the result in 3. Indirectly, they have the same meaning. All right, okay, so this is what we are going to do. So now we are going to look at what? The solution. Okay, but before we look at the solution, any questions based on what I've said so far? Is there any statement that I've made that you think didn't sync well with you? Okay, we are fine. So now let's go and look at the questions that we have there. The question 1 has everything to do with the range of a function. Okay, so the range of a function. Okay, however, so now let's see. Okay, solution to question 1 is, okay, and let's look at the question is to find the range of the following functions. Okay, so these are the functions from A up to F. E and F obviously will not be for me. It will be, okay, your assignment. So I'm going to handle maybe the first 4. So let's look at what are we giving the function in the mapping form, but we extract in the relating form. So that will give us what? 2 minus 5x. So f of x is equal to 2 minus 5x. So now this is what we are going to do. First step, okay, we are going to do what? We let, okay, y be equal to what? F of x. So this implies that your y will be equal to, what is your f of x? 2 minus 5x. Okay, what is your next step? Your next step is to make x the subject. Remember, that was the second step. Make x the subject of the result in was step 1. So this is the result in step 1. So we are going to do change of subject, but that one you don't have to write, okay, making this the subject, just like I told you in the inverse situation. So we go and do our change of subject. We move this one here. So you get 5x is equal to, then this one comes here, it will be 2 minus 1. You write it again before you divide, or because I'm going to treat this one as a single fraction, okay, I will write it again before I divide. Otherwise, then you can divide it by 2, divide it by 2, divide it by 5, divide it by 5, divide it by 5. Okay, in that case, you will show your division. You don't have to write it again. Just okay, right? But here, I'm going to treat this as a single fraction. So it's missing that when you use a term, so I'll write it again before I divide. So over 5, okay, over 5. So in effect, I'll get x is equal to 2 minus y over 5. Okay, so now you can see we are through with step what? Step 2. Okay, we've made that the subject. It says find the domain of x. So it means we are finding the domain of this function, x. So you come and use your technique in finding the domain of the function. And you see that the domain here will be in terms of y. The domain will be in terms of y because this part of the function depends on y. So your restriction here, if any, will be in terms of what? Y. So, and like I said, immediately you get the domain in terms of y. Because it is in terms of y, it automatically becomes the range. It's my point well made. Because it's the range that must be in terms of y, not the domain. Hello, it's my point well made.
Yes, please.
Okay, so now we are going to find the domain, which indirectly is the range. Okay, so somebody can write for the range, but before you write that, or even before the domain, before you write that, remember I've told you, investigate whether you have a restriction. It's when you have a restriction that you write for the domain, or in this case for the range, because you know that the domain will be the same as what the range. So you can use the two interchangeably, but you have to conclude with the range anyway. So in this case, let's see. You have a variable in the numerator. You have restrictions.
No, please.
No. The denominator, do we have restrictions?
No, please.
We don't have a restriction because there is no variable. So in this case, it means, okay, you don't have to come and write them because there is no restriction for you to go and find before you can conclude. So I am going to indirectly, okay, write this implies, but that step that I'm going to write, as you mature, you can take it out. This implies domain, x. So I can write DOM. Let's use the notation. So DOM of x, okay, will be equal to, so the domain of the function, of the x that we have here will be equal to, okay, we said it will be y is such that y belongs to a set of real number with no restriction. But as you mature, you know straight away you can come and write, therefore, the range, okay, here there is no notation, okay, of the range of f of x, okay, will be equal to, okay, what we have here, y is such that y belongs to what R. Because the last step we said the range, okay, will be the result that we had in this. So the range will be this result. Is that clear?
Yes, please.
Okay, so as simple as that. But I've said this particular step, as you mature, you can take it out. And straight away, immediately you get this, you come and write the range straight away. All right. Hello? Are we all fine?
Yes, please.
Okay, so that will be it for the very first example. Okay, we are going to subject, okay, the second question through the same concept. But before we do that, let me capture and send it to you. Let's look. Okay, so we are going to look at our second question, which is the B. So B, what are we doing? Also the function in the arrow form. Okay, but we extract our G of X, okay, in what? In the relating form. So 2 minus x, this is what we have. Okay. All right, so now we know the function. Let's proceed to find the image of what? Sorry, the range of what? Of this function. Okay, and you can see that the range, just like I said, will be your image point. Okay, I mean your value that your object will map onto. So in this case, okay, if we're asked to find the domain of this function straight away, we know expect. With this one, numerator, no respect to denominator, there is. So 2 minus x, but we are not finding the domain. Okay, so we generate an expression that will help us find the domain, okay, of that function, then we move on to get the range. So first step, let y to be equal to our function, which this time around is g of x. So this implies that your y will be equal to x over 2 minus x. The next step is to make x the subject. Okay, so in making x the subject, we need to cross multiply. So you get y into 2 minus x is equal to what? X. We have 2y minus xy is equal to x. So this time around, we have 2 terms in x. So it means one on each side. We have to move. And remember the advice that I gave you in terms of carrying out this movement. Okay, always one of them will be ideal. And the ideal will be the one that will involve, okay, the less number of negative terms after you moving. So if I move this one to this side, I'm going to get this to be negative, this to be negative, and this one will come here and also negative, 3 negative terms. However, if I maintain this and move this one to this side, I'm going to get positive, 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 so 3 positive terms. So it means it will be better I move to this side. So in my mind, I am moving to this side, but however, I will still write it here. So I'm going to have, moving this one to the side, I'm going to have x, okay, y, then what, plus x. Okay, and it's equal to, I move this one to the side, or x plus xy, the same thing. It's equal to 2y. Someone equally can write 2y is equal to x, okay, plus xy, or xy plus x. Am I clear now? Okay,
Yes.
but remember we are making x the subject, so we can factor out x here. So that would give us what? Y plus 1, and it's equal to what? Okay, 2y. You write it again before you divide by this. So we are going to get x into y plus 1 is equal to 2y over y plus 1 over y plus 1. So x now will be equal to 2y over y plus 1. Is that clear? Hello, are we fine?
Yes, please.
So step 2 done, the change of subject. Now step 3 kicks in at this point. So step 3 says, what do? We are supposed to find the domain of the resultant function here. So you are going to find the domain of this function, and you can see that it's in terms of y. So your domain will be dependent of y. And once it's dependent of y, it becomes automatically the range. Point well made. Okay, so let's see if there are restrictions. Numerator, you see a variable there, but is there a restriction?
No, please.
Okay. Denominator, there is a variable there. Is there a restriction?
Yes, please.
Okay.
So we are going to, once there is a restriction, we cannot straight away draw our conclusion. So we are going to write, at the normal circumstance, we are supposed to write for the domain. Like here, because we know that the domain will coincide with the range, I'll write for the range. Okay, for the range, I'm going to get what? My denominator, which is y plus 1, should not be equal to 0. So I'll come and get y should not be equal to what? Minus 1. So now I can draw my conclusion. Therefore, the range of which function, g of x, okay, will be equal to, remember, it's x, sorry, y is such that y belongs to a set of real numbers, okay, y not equal to minus 1, then you close it. Apart.
I try.
Hello, who wants me to go over and at which point? Okay, so far so good. All right. Okay, so this is it. So it means, so that's the more reason why I spent more time on the domain, because I knew that you need the domain in finding the range. So if your domain is not strong, finding the range equally will be problematic. So take note. All right, so we are going to look at the next. Okay, this will go. Obviously, we are looking at the solution now. I've written the solution. Okay, already. So in this case, we go to C. Okay, see what are we giving? Okay, also in the mapping form, I will extract in the relating form. And what do we have? X plus 3 over X plus 2. The same concept. Okay, what do? We are going to make the representation. So we let, okay, y be equal to what? H of X. So this implies that your y will be equal to your X plus 3 all over X plus 2. Okay, so at this point, what do? We are going to solve for X. So in solving for X, you will get y, you cross multiply X plus 2 is equal to what? X plus what? 3. So we'll get what? Xy plus 2y is equal to X plus 3 this time around. So again, that same situation. Okay, a term containing a variable of interest on each side of the equal to. So we have to move. So let's see whether which movement will be better. If I move this one to this side, this will be negative. This will move to this side. This equally will be negative. Okay, so I'll have two negative terms. Okay, if I move this one to this side and then also this term will be negative, then take this one, this will be negative. So it means you get, for each movement, you get two negative terms. So at this point, you know, it stands to reason that any movement in terms of the direction will be okay, will be fine. So we go our traditional movement, that is maintain the term here and move the other term to the side. So on that note, I'm going to get what? Xy plus X should be equal to, then it will be 3, this will be negative, so I'll write that one as my second term. So now I factor out X, I will get Y plus 1 here is equal to, again, 3
Mr.
minus.
Hampton,
Yes, please.
Please,
Oh, sorry, forgive me.
please,
It's minus, I understand. I've gotten it. Okay, so you equally learn from, okay, my mistake. Okay, which is especially when it is trivial. Like I always say, maybe it's the way of God. Okay, speaking, okay, to you through me, that you should equally be mindful can happen to you. So what do? You write, okay, that again. Okay, and divide by y minus 1, okay, 3 minus 2y over y minus 1. So you get x to be equal to 3 minus 2y over y minus 1. So here, obviously, this is the function that we are going to find the domain. And the domain automatically becomes what? The range. So now what do? Okay, numerator, obviously no restriction, though there is a variable for restriction to take place, square root will come. Denominator there is, so I can come and write for the range. Okay, my denominator function, which is y minus 1, should not be equal to 0. So I'm going to get what? Y should not be equal to 1. So at this point, I draw my conclusion. Therefore, because I know my constraint, the range, okay, of what? My function J of what? Is it J? No, forgive me, H of S. Or I can write H of S without the of. You simply write the range of, is the same thing. Okay. So let me add this. Then it's equal to, again, it's in terms of y. So y, it says that y belongs to the set of real numbers, all right. However, your y should not be equal to what? 1. Then you close it. Are we all fine?
Yeah.
Okay, so this then will be it for C. There is one more question for me. Okay, I need to do it so that you appreciate how to do this one as well. So far, all of them, you can see that this is linear. In this function, it is rational, but the numerator is linear, the denominator is linear, just like this one. So you are going to look at a situation where your expression of function is quadratic and how to deal with that. So quickly, let's disconnect and come back and continue.